Hi, welcome to EcademicTube. The question of discussion is from the probability distribution function. The joint probability density function of a two-dimensional random variable x and y is given below. Here we have given that it is a two-dimensional random variable in the form of x and y that is given below. F of xy is equal to 2 for all 0 less than x less than 1 and 0 less than y less than x. These are the range of y and this is the range of x on which our distribution function is defined. So now we have to find out the marginal density function of x and y, means we have to find f of x or f of y. Secondly, we have to find out the conditional density function of y given x. And in third, we have to prove or we have to check either x and y are independent or dependent random variable. So now we will discuss them one by one. First of all, we will find out the marginal density function of x and y. So we have given, firstly we have to check either it is a valid density function or not. So for a validity of density function, we have to prove either integration in the range of x and y is equal to 1. So the range of x was 0 to 1, 0 to x, f of xy 2 dy dx is equal to, with respect to y, we have 2y 0 to x integration from 0 to 1 dy, sorry, dx. It will be equal to 2x 0 to 1 dx, that is equal to integration of x is x square by 2 to cancel from 0 to 1. Now we will put the limit 1 square minus 0 square is equal to 1. Hence it is true that it is a valid density function. So now if it is a valid density function, then we have to find out the marginal distributions of x and y. So now we will find out the marginal density function of x, that is given by the integration from minus infinity to infinity, or we can say that range of y with respect to y. The range of y was 0 to x to d1, that is equal to 2x, sorry, 2y. Here the integration of constant is y. So we will have 2x minus 2 into 0, that is equal to 2x for all 0 less than x less than 1. It is the density function of marginal density function of x. Similarly, in the first part, we have to find out the marginal density function of y, that is equal to integration of minus infinity to infinity f of xy with respect to x, that is equal to 0 to 1 to dx. 2x, that is equal to 2 whole 0 less than x less than 1. In B part, we have to find the conditional density function f of y given x, that is equal to f of x, means to say joint density function divided by the marginal density function of x, that is equal to joint density function is 2 and the marginal density function of x is 2x divided by 2x, 2 to 2 cancel, so it will be equal to 1 by x. The conditional density function of y given x will be equal to 1 by x. In third part, we have to find either x and y are independent. So we can say that the two-dimensional random variable density function will be independent if and only if it is equal to the multiplication of their marginal density functions. So f of xy was 2, that is equal to f of x was 2x into f of y was 2, which implies that 2 is not equal to 4x. So we cannot say this. We can say that x and y are not independent. There is another way to also to prove that either x and y are independent. That is, if we will find out the correlation between x and y, and if covariance between x and y becomes 0, then we can also say that x and y are independent, and if they are not equal to 0, then we can say that they are not independent. I hope you understand the problem. Thank you.